Please welcome to the stage Electronic Arts Chief Strategy Officer Mihir Vaidya and Runway co-founder and co-CEO Cristobal Valenzuela.
Hey everyone, it's me again. I'm really excited to chat with Mihir. There's a lot to cover in games, and getting your perspective here will be like a privilege, to be honest, on like trying to understand really how you guys are just thinking about what's next. And I know we spent a lot of time thinking about this. We were actually speaking about it yesterday very deeply, so hopefully we can share a bit more about some of the same insights. And one thing that's, for me, remarkable from the gaming side is when we think about AI, it's actually like AI has been working the most and the longest in gaming, right? When you think about like procedural generation, like NPC behavior, adaptive difficulty of like the systems that you play with, those are all AI systems some way, right? But there's this new thing now that we're all thinking about, which is like generative AI, right? So how do you think this fits within that continuum of continuous like technology and AI systems you already have in games?
Yeah. Well, first off, thank you for having me. It's incredible to see how big Runway's gotten and just the journey you've all been on for the last few years. I think it's a good place to start because, as you said, I think it's underappreciated that games have very much been the proving ground for AI for the majority of actually the field's history. If you zoom out and look at the last 40 years, a lot of what powers modern AI has its roots in video games. GPUs, agents that have learned RL in interactive environments, and I could go on and on. I think in very many ways, games are these both testing and training grounds for AI. Now, of course, a lot of the ways in which we've been consumers and drivers of AI has been in a paradigm that's you would describe not as generative but as symbolic. Procedural generation, NPC logic, behavior trees, matchmaking systems, basically systems that are deterministic, reliable, controllable. And I think as you go further out on that continuum that you described, you get to generative AI. And generative AI meaningfully expands the space of what's possible in the context of any domain, including very much video games, both for developers and players. But I think one of the things I notice as we talk about generative AI in our industry, there's this orientation towards neural everything. And I think that's a little bit simplistic. And what I mean by that is games very much are not domains that can be fully probabilistic. And I'll bring this to life with an analogy. Let's say that you and I wanted to solve a very complex math problem. Maybe I'll pick a simple one, 17,423 times 300. I know you can do that in your head. I struggle with it. And so we'll ask ChatGPT or any modern chatbot powered by an LLM that has trillions of parameters. What you'll notice is that no matter how big these LLMs get, they won't try to just probabilistically or stochastically or get to the answer by thinking harder. What they'll usually do is interpret the question in a very neural way, but then call on a symbolic solver, a calculator, to get to a precise answer. Because there's certain things in life that simply should be precise. They should be deterministic.
Right.
An input leads to an output. And I think in the same way, games have certain constructs that make them fun that shouldn't just be hallucinated. You don't want the rules of basketball suddenly just being determined probabilistically. Maybe you do.
No, that's true.
You don't want the physics of an F1 car to be hallucinated either, right? And so I think as I personally, and as I think we think about the next frontier of AI, we definitely don't think generative AI is the end post. We think there's another frontier ahead of it that takes the best of the two paradigms that preceded it, both symbolic and generative, and fuses them, what some call as a neurosymbolic architecture that gives you the benefit of generative systems that are truly emergent and have this incredible unlimited possibility space, but also give you the benefits of determinism and control and reliability.
So it's a hybrid approach, something where you can combine the best of both worlds.
That's right.
Yeah, I agree. There's something about like both the probabilistic and deterministic aspect of these models that can become much more powerful if they're grounded together or made together. I guess somehow related, but you were telling me about how some of the engines you guys have, Frostbite and some of other engines you guys have are pretty made for this particularly hard problem in graphics, which is real time. Like the latency between players needs to be like perfect, and like the way you do the engineering to make it perfect has been like years in the making. Like from an implementation standpoint, that might also pose maybe challenges or differences to how you think about this maybe neural like rendering or AI system.
Yep.
Is this something you guys think about in terms of real-timeness of the models and the ways you interact with them?
Yeah, absolutely. Maybe I'll actually just ask the audience, how many of you, play video games? And I won't take it personally. All right, that's a healthy number. There are some of you that don't. You should try it tonight.
Where should they start?
Definitely FC. It's
Okay.
the best game in the world, followed by Battlefield, followed by The Sims, and all the other EA titles. And there's some others that matter, I guess. But one of the things you notice if you play games are that they're actually fundamentally different mediums of entertainment relative to all the other forms of media out there. And it's exactly what you described, Chris, that makes them different. They're real time. If you're watching a movie or a TV show, you don't, as a consumer, expect for the world to respond to you. But in games, they have to respond to you,
Right.
not just once in a while, often 30, 60 times, per minute, with frames that go 60 frames per second.
And if they don't, you get mad.
You get real mad. You get really, really mad. It's sometimes fun to just see, the calls to our customer service team. But really, there is a real performance, expectation, and I think as a result, that results in some real constraints as it relates to the deployment of AI in the context of video games. First and foremost, the AI has to be able to receive, process, and react to continuous input from players. Once it does that, it has to also introduce deep interactivity, and that's actually a fundamentally different thing. Let's imagine that you and I were watching the F1 movie, and what we want is for the AI to model what it looks like for the car to bend, around the curve on the track. As long as it looks right, we're happy as audiences. In a game, you need for the drag coefficient on that wheel to be felt by the player. If it doesn't feel right, it doesn't matter. So it can't just look right, it has to behave right. Now let's say you solved continuous input and interactivity. Well, now the AI has to account for scale and synchronization, meaning many of our games, in fact, the majority of our games today are experienced as social products, right? They're places where you don't just spend time on your own, you spend your best time with your best friends. And so your experience, let's say you and I were playing FC, if I kick the ball and score a goal on you because the AI didn't react in time on your end, you're gonna be a little bit mad. So it has to be synchronized at scale between tens of players, hundreds of players, thousands of players. And let's say you figured all that out, then you also have to do the whole latency thing, which is 60 times per second, endlessly for many, many, many hours. So that combination means that when you're deploying AI in the context of games, you're not just solving a content generation problem, you're actually solving a complex systems coordination problem.
Right.
And it means that it's not enough for things to look real. That's what you'd call a dream, things that look real. It has to behave real, which is what you'd call a simulation.
Interesting. And I guess in that behavior of like it needs to both look real and feel real, I feel like a common like trope or approach I hear in games is this tension between like efficiency and how do you make like things faster and be more effective with what you already have, and creative intent, right? How you make it so you can leverage these models for a much more creative ideation process. Like, do you think that the AI changes the game or the equation in how we balance those two things?
Yeah, I try to think about this question, and I think many variants of this question with a first principles sort of approach, which is first just asking the question of what even is creativity? Where does it originate?
Tell us, please.
I think there was, a few of your speakers have probably alluded to this already, and I think all of us would not dispute the fact that the origin of creativity is very much the human mind. Ideas, intuition, taste, that's where it originates. It doesn't originate on a piece of paper or on the screen or some other tool. It's in the human mind. And as game makers, our fundamental quest has always been converting what's in the human mind to a playable experience. In fact, I'd go as far as saying the business of creativity at large, all of entertainment, is a quest to close the gap between imagination to creation. And you close that gap by either creating a bigger bridge or a smoother bridge, so you can go faster across it, or you can go in a way that's perhaps more cars can go across it and you can explore wider territories. But nowhere in there is this notion that we're going to leverage the tool exclusively in the context of efficiency. I think it's a very reductive kind of construct. It's actually to increase velocity, to increase creative space, with very much the human needing to be as the source of origin, because that's where creativity originates. So I think that's, to me, really the ultimate quest here. And one of the unlocks that I'd like to see is in the realm of control. And you and I have had this conversation. Yep. I think, why do we sometimes struggle with these next generation tools? Or why do we feel like they're left wanting in few ways? It's not necessarily always just because they're not capable. I like to say they can often produce very, very pretty pixels. They just don't feel like the right pixels.
Right.
And why do they not feel like the right pixels? It's because our intent is not transcribed. Well, why is that? It's because the intent that we have, the aesthetic styles that we have, they're not necessarily well understood by the off-the-shelf generic black box models. And so I think control is very much the next frontier. And for us to cross that frontier, there has to be deep customization and workflow work that has to happen. And I think when we do that, we're going to start seeing these bigger bridges, these smoother bridges, but bridges that still start with the human imagination.
Yeah, I guess similar to what we were speaking just before about maybe graphics traditionally was solved by control first and like rendering later, and it feels like we're inversing that, right?
That's right.
We solve rendering first, and now we're figuring out control, to your point, right?
That's right, because I think historically, whether it's in game development or any sort of field that involved computer graphics, you started with these base primitives, right? Polygons, you added meshes and textures, and then lighting and so on. But you started with these very foundational building blocks where you can exercise a ton of control, and then you solve for fidelity. And that's why I think you've shared an example in the past where you go from Toy Story 1 to 5, but the difference between 1 to 5 is more about the fidelity of what is the end result as opposed to the baseline control. Today we have these models that can produce these incredible, super realistic outputs, the highest levels of fidelity, but you don't have those baseline primitives to work with to exercise control.
So that's what we need to figure out. I guess Kathy was speaking about this idea of it feels like a new medium at some times. You're building these systems and you're combining them with like maybe game mechanics or film mechanics. And everyone is trying to contribute in some way to the shaping of this new thing. I guess Kathy was speaking from the film production side of things, and how do you make sure that the systems have that human storytelling component in them? How do you think the gaming industry, maybe you guys, are thinking through shaping that evolution of this new medium and AI more broadly as well?
So I think we try to think about the impacts of AI across sort of 3 dimensions. We've touched upon the first one, which is efficiency. Sure. And I think, again, efficiency is really just about how we leverage AI to make games. And here, really, the frontier is control. And I think efficiency will be expressed as much in the form of velocity and speed and quality as it is in the form of, for instance, cost. But I think the 2 sort of vectors that get me much more excited are what I describe as expansion and transformation. Expansion is about how we leverage AI to expand the very nature of a game, what's possible within a game. And transformation is more about how we leverage AI to conceive of entirely new forms of entertainment that we probably don't have names for yet.
Right.
Expansion, an example is one of the things that gets, I think, most players around the world super excited is an experience that is increasingly emergent, it's increasingly responsive, it enables possibilities that are just so unpredictable and surprising.
It's like an open-ended world you can
Yes.
explore.
So if you've ever played The Sims, The Sims is this incredible franchise coming up on its 25th anniversary now.
Wow.
Yeah, and The Sims, as I think over its lifetime, engaged over 500 million players. And when you speak to many of those players as to why they love The Sims so much, you'll discover that not any two of those players, have had the same experience. Almost every one of your playthroughs will be different. And the reason is, in The Sims, there's almost 1 trillion different permutations of how you can play through the game.
Interesting.
Starting from the species of the sim that you take on, the life stage you start with, the personality traits, the likes, dislikes, preferences.
You take care of them.
Yeah, and so
Yeah.
the playthrough is different. But even with 1 trillion permutations, there should be 1 trillion to the trillion to the trillion to the trillion possibilities, actually, of what is possible in The Sims. And this is something that AI, for instance, could potentially unlock. What if I could not just play through as a school teacher, but also as a doctor, also as a fireman, and so on and so forth? And I think doing that within the constraints of a game, within the progression systems, is what will ultimately make it fun. So that's something that truly excites me, is the expansion possibility. Now, here, one of the constraints is not just the capability of AI, but it's also the fact that games are incredibly performance intensive. If you ever talk to a game developer and you ask them about how much of the compute they're using as it relates to in a console or a PC, they're squeezing every inch out of it, right? There's almost always more features that they want to put in because they're straining the performance to the max. And now if you add AI, it adds to that burden, right? Especially when you need to achieve 60 frames per second with no latency for lots of different players at the same time. So we'll work through that. And the thing that truly gets me excited, though, is this transformation idea. And an analogy I try to use is when YouTube kind of came around, or when the smartphone era and the internet era came around, you'll remember that a lot of people were like, wow, like I can be Steven Spielberg. And a lot of folks that were in more traditional entertainment were like, oh my God, everyone can now be Steven Spielberg. And reality turned out quite different. There's still only one Steven Spielberg. But there are all these incredible creators like Mr. Beast and Kai Cenat, folks that I grew up with, who honestly shaped new forms of entertainment that we don't have names for at the time. We didn't have names for, but we do now, right? And I think the same will occur in the context of games as well as almost any other kind of media industry. And that's, I think, where there'll be almost a level of value creation we've never seen before in history.
I like that idea. By the way, I love The Sims. I used to spend so much time playing The Sims back then. Well, speaking about favorite games, I have to ask you, like, what's your favorite game?
There's probably not that many folks that are big cricket fans in the audience, but
Maybe they are. I don't know.
there we go. Yes. All right. The three of us can, rally and create a club here in New York. But I grew up in India, huge fan of cricket. It's one of the fondest parts of my childhood, and cricket was actually one of my favorite EA games. We made Cricket 2000, Cricket 2007, and it's been my quest for quite some number of years to try to bring cricket back, especially because the game has meaningfully evolved. And so, yeah, my favorite cricket game still, lifetime.
So they were announcing that.
Cricket 2007. I wish I could just say that and it happens, but it turns out there's a lot of folks that need some convincing, but that's right.
Yeah, I'd love to play it at some point. I think the interesting thing that I think a lot about is what's something like you just like overall just couldn't do before. We're talking about performance and speed, and there's a lot of things that AI models can do today. We have this avatar model that allows you to create consistent real-time conversations. I'm sure there's way more stuff you guys have thought about that you can talk about that you just couldn't do overall before in terms of graphics or entertainment or interactions.
Yeah.
And if you can speak about more about that.
So I'm going to give you a slightly potentially boring example, but I think it's a real example. And it's one that I think speaks to how in many small ways AI can have a profound impact when you add it all up. So the example I'm about to share is, if those of you who are familiar with rendering, you'll know that modern rendering pipelines use a methodology called physically based rendering. And physically based rendering is simply a rendering methodology that allows for light to interact with objects in ways that feel increasingly realistic. So, if you ever play a modern video game, you'll notice that light just bounces off of objects in ways that feel so beautiful and so realistic. The metallicness of the object is right, the roughness, the texture, the transparency, and that adds to the sense of immersion and realism. Many of our games and our franchises transcend many generations of technology. FC, Battlefield, Madden, Sims, Skate. These games have been in existence for more than 20, 30, 40 years even. And so we have a lot of assets in the libraries of these franchises that were conceived of a time when PBR or physics-based rendering wasn't a thing. And so we're now able to leverage AI to modernize these assets and bring them into PBR pipelines, make them PBR compliant, which would have taken armies of folks to do in the past, and honestly is not something you can prioritize in the context of all the things you have to do as a game developer, but now is something that's possible. And it meaningfully expands the nature of the worlds that we have because there's so many more assets that can be part of the mix. And so that's just a slightly boring example, but again, to me, it's super powerful because it changes a lot of for the player experience, the developer experience.
The last question I want to ask you is, you run strategy, and I'm assuming you have this question come often when you think about plans and roadmaps, which is, how do you kind of strike a balance between okay, these short-term things that we can do today and tomorrow and next week to make sure we're building that frontier, but then how do you think about the long-term approaches that are maybe projects that are just overall longer to develop and take? Can you do both? Just generally from a strategy perspective, how do you think about those two things?
Yeah, I try to think about it in kind of two different sort of dimensions. And I'm a student of strategy for sure, but I'm also a student, honestly, of technology. I studied math, and one of the benefits of my education was that I ended up studying under Jeff Hinton and some of the folks that are the kind of, let's call it, founders of modern AI. So I have a deep appreciation of the fact that this technology very much represents an exponential curve. And so you can't just think about it in the now and today, but very much have to think about it in the future. So the two kind of dimensions by which I think about it is what will change and what won't change. When it comes to what will change, we know for a fact that there's going to be meaningful value across the dimensions of efficiency, expansion, and transformation. Efficiency may be more near-term, expansion of games may be more mid-term, and transformation of games altogether will be longer-term. Right. So we need to have sort of efforts across all three of these vectors, recognizing different timelines, but they have to exist in parallel as opposed to sequentially, just given the lead times involved. It's also equally important to think about what won't change. What is timeless, despite AI? And for instance, in our domain, that means the value of IP and brands, the importance of communities and network effects, the criticality of global distribution, localization, culturalization. All of these actually arguably grow in importance, if not, are equally important in the future. And so how do we not just preserve them, but grow these as sources of competitive advantage as we move into the future? And so that's kind of how we think about our strategy, is straddling what will change, what won't change, and kind of making sure that in both directions we have, both near-term, mid-term, and long-term efforts.
Nice. That's a perfect framework to close. This idea of just make sure you remember what doesn't change. Mihir, thank you so much for the time. It's been great chatting with you. I appreciate it.
Thank you for having me.
Thank you, guys. Thank you. It was good. Here.